July 1st, 2025, astronomers at the Atlas Survey Telescope in Chile spot something racing through space at 130,000 miles per hour. That's the fastest speed ever recorded for any object visiting our solar system. But speed isn't the only thing that makes this visitor special. This is 3I/Atlas, the third confirmed interstellar object ever detected. It came from another star system entirely, and its size could rewrite everything we thought we knew about cosmic wanderers. How big is it really? Where did it come from? And why does it move like nothing we've ever seen before? If you value documented space science like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from NASA's Jet Propulsion Laboratory and the European Space Agency. Now back to the story. You're looking at an object that shouldn't exist. The first interstellar visitor, 1I/Oumuamua, was roughly 400 meters long when it passed through in 2017. The second, 2I/Borisov, measured about 1 kilometer across in 2019. Now Atlas arrives with a nucleus estimated between 11 and 20 kilometers in diameter. That makes it 15 times larger than Borisov and 50 times bigger than Oumuamua. For perspective, that's roughly the size of a small city hurtling through space at speeds that defy our solar system's physics. The asteroid. Terrestrial impact. Last alert system wasn't even looking for interstellar objects when it captured Atlas. The telescope network is designed to spot asteroids that might threaten Earth, but Atlas immediately stood out because of its trajectory, a hyperbolic path with an eccentricity of 6.141. Any object with an eccentricity above 1 is not bound by our sun's gravity. Atlas crushes that threshold, making it the most hyperbolic interstellar object ever detected. Dr. David Jewett at UCLA confirms the size estimates using the Hubble Space Telescope. On July 21st, 2025, Hubble captured Atlas at a distance of 277 million miles from Earth. The images show something remarkable, a teardrop-shaped cocoon of dust and gas surrounding the nucleus. This coma stretches roughly 50,000 kilometers across, larger than the planet Neptune. But here's what makes astronomers nervous: the tail formation. Most comets develop tails that point away from the sun as solar radiation pushes dust and gas outward. Atlas does something different. Early observations from the Vera Rubin Observatory show hints of a dusty tail that points directly toward the sun. Dr. Stuart Bryce Boland suggests this indicates massive particles being ejected in the solar direction, particles too heavy for solar radiation to blow away at Atlas's current distance. The numbers get stranger the deeper you dig. Atlas entered our solar system from the direction of Sagittarius, near the Milky Way's galactic center. Unlike the previous two interstellar visitors that came from the northern celestial hemisphere, Atlas approached from the south. Its trajectory is tilted 175 degrees with respect to the ecliptic plane, essentially traveling backward compared to everything else in our solar system. June 25th, 2025, pre-discovery observations from the Zwicky Transient Facility reveal Atlas had been visible for weeks before anyone noticed it. Amateur astronomer Sam Dean traces additional Atlas observations back to June 5th. The reason no one spotted it earlier? Atlas was passing in front of the galactic center's dense star fields, where a comet would be nearly impossible to distinguish from background stars. July 2nd, 2025, multiple telescopes confirm Atlas is actively outgassing. The Deep Random Survey in Chile, Oumuamua, Lowell Discovery Telescope in Arizona, and the Canada-France-Hawaii Telescope all detect a marginal coma with potential tail elongation 3 arcseconds in angular length. This confirms Atlas is a comet, not an asteroid. Its icy nucleus is sublimating as it approaches the sun. The Nordic Optical Telescope provides crucial follow-up observations the same day. Astronomers David Jewett and Jane Liu confirm Atlas appears clearly active with a diffuse appearance. The 2-meter twin telescope at Tidy Observatory captures additional evidence of cometary activity. Every observation points to the same conclusion: Atlas is shedding mass as solar heating vaporizes ice from its surface. By the time the Minor Planet Center officially designated Atlas as 3I on July 2nd, astronomers had collected 122 observations from 31 different observatories worldwide. The speed of confirmation was unprecedented. Previous interstellar objects took weeks or months to verify. Atlas's extreme hyperbolic trajectory made its alien origin immediately obvious. August 2025. Spectroscopic analysis reveals Atlas contains water ice, carbon monoxide, carbon dioxide, methane, and ammonia, similar to comets in our own solar system, but with different ratios. The carbon monoxide abundance relative to water suggests Atlas formed in a colder environment, farther from its parent star than most solar system comets. The Atacama Large Millimeter Array detects radio emissions from Atlas's coma, confirming complex organic molecules. These carbon-based compounds formed billions of years ago around another star. Now they're being released into our solar system, seeding interplanetary space with alien chemistry. Dr. Matthew Hopkins at Oxford suggests Atlas might have originated from the Milky Way's thick disk, a vertically extended region of older stars. If true, this would make Atlas 7 billion years old, more ancient than our solar system itself, the oldest comet ever detected. Carrying chemistry from the galaxy's earliest epoch, September 12, 2025, Atlas passes through Earth's orbital distance from the Sun, still racing inward at maximum velocity. Ground-based observations show the coma has grown redder throughout July and August, indicating evolving surface composition as different ices reach sublimation temperature. Water dominates close to the Sun, but carbon monoxide and methane become prominent as heating continues. The mass loss calculations are disturbing. Atlas is shedding roughly 10,000 tons of material per day. At this rate, the nucleus will completely sublimate within 10 million years, nothing compared to the billions of years most solar system objects survive. We're watching an interstellar visitor slowly die as it races past our Sun. October 30th, 2025, Atlas reaches perihelion, its closest approach to the Sun at 1.36 astronomical units. That's roughly 200 million kilometers, just inside Mars's orbit. At perihelion, Atlas will be moving at its maximum speed of 68 kilometers per second relative to the Sun. The gravitational acceleration from our star pushes its velocity to levels that would shatter most objects, but Atlas holds together. Rotation period measurements show it spins every 8 hours, fast enough to indicate a solid or semi-solid body with significant structural integrity. This isn't a loose pile of rubble held together by weak gravity. Atlas survived millions of years in interstellar space because it's built like a rock. The European Space Agency calculates backward trajectories to trace Atlas's origin. The comet was ejected from its home system roughly 3 million years ago, traveling between 40 and 80 light years to reach us. Several candidate star systems fall within this range, including Wolf 359 and Gliese 674. Computer models suggest Atlas spent those 3 million years accelerating through gravitational encounters with countless stars and nebulae, each interaction adding momentum like a cosmic pinball machine. Ejection requires violence. Something threw a 20-kilometer comet out of its birth system with enough velocity to reach interstellar space. The most likely culprit is a close encounter with a migrating gas giant, a Jupiter-sized planet that moved inward during system formation, scattering smaller objects into hyperbolic escape trajectories. Planetary migration models show that gas giants can eject objects up to 50 kilometers in diameter when they spiral inward during the first 100 million years of system evolution. During its interstellar journey, Atlas survived temperatures near absolute zero, cosmic ray bombardment equivalent to millions of years of Earth's radiation dose, and impacts from microscopic dust grains traveling at hundreds of kilometers per second. The surface darkened over millennia as organic compounds were irradiated into complex carbon chains. This process, called space weathering, created the protective coating that now shields Atlas's interior ice from immediate sublimation. Dr. And Alan Fitzsimmons at Queen's University Belfast runs detailed thermal models to understand how Atlas maintained structural integrity across interstellar distances. The calculations suggest the nucleus differentiated during its original formation. Heavy materials sank toward the center while lighter ices concentrated near the surface. This layered structure explains why Atlas rotates as a solid body, rather than tumbling chaotically like a loose rubble pile. November 2025, Atlas emerges from solar conjunction, visible again in pre-dawn skies after disappearing behind the sun's glare. The comet has dimmed considerably, its apparent magnitude dropping below 12 as it moves away from peak heating. Telescopes worldwide resume tracking its retreat toward interstellar space. Amateur astronomers with 8-inch telescopes can still spot Atlas as a fuzzy star-like object in the constellation Leo. The reappearance reveals something unexpected. Atlas's coma has developed a subtle green tint characteristic of diatomic carbon molecules, C2, being excited by solar radiation. This same green glow appears in solar system comets when they approach within 2 astronomical units of the Sun. The presence of C2 confirms Atlas contains significant amounts of organic carbon, possibly including complex molecules like amino acids and nucleotide bases. Spectroscopic analysis using the Very Large Telescope in Chile detects emission lines from water vapor and carbon monoxide, hydrogen cyanide, O, and formaldehyde in Atlas's tail. The ratios differ significantly from typical solar system comets. Atlas shows 3 times more carbon monoxide relative to water, suggesting it formed at temperatures below 50 Kelvin, colder than Pluto's current surface temperature. The Hubble Space Telescope captures what may be final detailed images before Atlas fades beyond detection limits. Despite months of outgassing, the nucleus appears structurally unchanged. A protective layer of dark, non-volatile material shields underlying ice from direct solar radiation. This coating formed over millions of years of cosmic ray bombardment and micrometeorite impacts. The surface albedo measures just 4%, darker than charcoal, making Atlas one of the blackest objects ever observed in our solar system. High-resolution images reveal surface features that suggest internal structure. Linear grooves run parallel to the rotation axis, possibly indicating layered ice deposits formed during the original accretion process. Bright patches scattered across the surface mark areas where recent outgassing has exposed fresh ice underneath the weathered crust. These active regions appear concentrated near the equator, where solar heating is most intense. Radio observations from the Goldstone Deep Space Communications Complex track Atlas's exact position to within 10 kilometers. The precision measurements reveal the tiny deviations in the expected trajectory, non-gravitational forces caused by outgassing acting like microscopic rocket engines. These jet forces are asymmetric, causing Atlas to precess slightly as it rotates. The effect is subtle but measurable, confirming active sublimation continues even at large distances from the Sun. If you value documented space science like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. December 2025, Atlas passes through the constellation Virgo, moving steadily away from the inner solar system. Its coma contracts as solar heating decreases. The spectacular tail that made headlines in July is now barely detectable, wispy remnants stretching behind the nucleus like cosmic spider webs. Radio telescopes continue tracking Atlas's chemical signature. The outgassing continues even at this distance, releasing water vapor, carbon monoxide, and organic compounds into the solar wind. This debris will orbit the Sun for millions of years, creating faint meteor showers whenever Earth's orbit intersects the trail. Marshall Eubanks, at Space Initiatives, calculates that several interplanetary spacecraft could observe Atlas during its hidden period behind the Sun. The Jupiter Icy Moons Explorer and NASA's Psyche mission are both positioned to study the comet when Earth-based telescopes can't see it. This coordinated observation campaign could capture unusual activity like nucleus fragmentation in real time. Atlas represents a collision threat we've never properly calculated. A 20-kilometer comet, traveling at 130,000 miles per hour, carries kinetic energy equivalent to billions of nuclear weapons. An impact would create a crater over 1,000 kilometers in diameter and trigger a global extinction event that makes the dinosaur-killing asteroid look modest. The Chicxulub impactor that ended the age of dinosaurs was roughly 10 kilometers across. Atlas is twice that size and moving 3 times faster. Impact simulations run by NASA's Planetary Defense Coordination Office show an Atlas-sized object would vaporize on contact and creating a fireball hot enough to ignite vegetation across entire continents. The resulting debris cloud would block sunlight for months, causing global crop failures and ecosystem collapse. Ocean impacts would generate tsunamis over 1 kilometer high, wiping out coastal civilizations worldwide. But the statistical odds provide cold comfort. Interstellar objects like Atlas approach from random directions with no advance warning beyond a few months. Our current detection systems are optimized for objects orbiting the Sun, not visitors from other star systems. The Atlas Survey Telescope network that discovered this comet was pure luck. The right instrument pointing in the right direction at precisely the right moment. The good news is such impacts are extraordinarily rare. The bad news is we can't predict them. Interstellar objects approach from random directions at unpredictable times. Atlas was discovered purely by chance when it reflected enough sunlight for our telescopes to detect. Most interstellar visitors probably pass through unnoticed. Dr. Robert Warwick estimates we detect fewer than 1% of interstellar objects that actually cross our solar system. Current models suggest a major interstellar impact occurs roughly once every 100 million years. The last mass extinction event, the Permian-Triassic boundary that killed 90% of marine species 252 million years ago, remains unexplained. Some researchers now speculate it might have been caused by an interstellar impactor that left no crater because it struck ancient ocean floor later subducted beneath continental plates. The discovery of Atlas forces revision of these impact probabilities. If interstellar comets can reach 20 kilometers in diameter, the potential for civilization-ending collisions increases dramatically. Objects this large carry enough energy to sterilize Earth's surface entirely. boiling the oceans and stripping away the atmosphere through hydrodynamic escape. January 2026, Atlas crosses Mars's orbit outbound, still shedding mass as residual solar heating supplements surface ice. The rotation rate remains steady at 8 hours in trios, suggesting the nucleus retains structural integrity despite months of mass loss. Spectroscopic measurements track the changing composition as different ices sublimate at varying temperatures. The Vera Rubin Observatory begins full operations this year, scanning the entire visible sky every 3 days. Its sensitivity should detect objects like Atlas when they're still beyond Pluto's orbit, providing years of advance warning instead of months. Future interstellar visitors won't catch us by surprise. March 2026. Atlas passes beyond the asteroid belt, rapidly fading as distance reduces the amount of sunlight it can reflect. Ground-based observations require longer exposure times as the comet merges with background stars. The European Space Agency estimates Atlas will remain detectable until September 2026 at the earliest. By then, it will be farther from the Sun than Jupiter, moving at 41 kilometers per second toward the constellation Lynx. The final observations reveal Atlas's true legacy. Mass spectrometer analysis of particles collected by high-altitude aircraft during peak outgassing shows isotope ratios unlike anything in our solar system. The deuterium to hydrogen ratio in water vapor from Atlas is 30% higher than terrestrial oceans, indicating formation in a stellar environment with different nuclear synthesis rates. Organic molecules detected in the tail include glycine, the simplest amino acid, and adenine, one of the 4 nucleotide bases in DNA. These compounds survived millions of years in interstellar space at temperatures near absolute zero, protected inside ice crystals that prevented radiation damage. When Atlas began sublimating, it released these biological precursors into our solar system's environment. Laboratory experiments confirmed these organic molecules remained chemically active even after interstellar exposure. University of California researchers mixed samples with simulated early Earth conditions and observed spontaneous formation of more complex compounds, including peptide chains and nucleic acid segments. The implications stagger. Atlas may have delivered the raw materials for life itself, but Atlas has already changed astronomy forever. Its discovery proves that large interstellar objects exist and occasionally visit our solar system. This forces recalculation of cosmic impact odds from sources we can't predict or prepare for. More importantly, it suggests the galaxy operates as a vast mixing bowl, constantly exchanging material between star systems through gravitational ejection and capture processes. Theoretical models now predict the Milky Way contains trillions of interstellar objects ranging from pebbles to small moons, all wandering between stars after being ejected from their birth systems. Most will drift through space until they are destroyed by stellar radiation or captured by another star's gravity. A few will seed new worlds with chemistry from their origins, continuing the galactic cycle of material exchange. Recent meteorite analysis reveals Earth has been collecting interstellar debris for billions of years. Microscopic grains with isotope ratios matching no solar system source have been identified in Antarctic ice cores and ocean sediments. Some of these particles show evidence of having traveled through multiple star systems before reaching Earth, accumulating chemical signatures from each stellar environment they encountered. The Antarctic samples include pre-solar grains, microscopic diamonds, and silicon carbide crystals that formed around dying stars billions of years before our solar system existed. These grains survived the collapse of the solar nebula and incorporation into primitive meteorites, eventually reaching Earth as cosmic dust. Recent analysis suggests some contain amino acids with chirality patterns different from terrestrial biology, indicating possible alien biochemistry. Deep drilling in Arctic permafrost has recovered organic molecules dating back 4 billion years, shortly after Earth's formation. The molecular structures include complex aromatic hydrocarbons and nitrogen-bearing compounds that could not have formed under early Earth conditions. These ancient organics show isotope signatures consistent with interstellar origin, suggesting our planet was bombarded with alien chemistry from its earliest epochs. The implications are profound. Earth's biosphere may have been contaminated or enriched by organic compounds from other worlds. The amino acids and nucleic acids forming the basis of terrestrial life might not be entirely terrestrial. They could descend from chemistry that originated around distant stars and traveled here on objects like Atlas over millions or billions of years. Panspermia, the hypothesis that life spreads throughout the universe via comets, asteroids, and other celestial objects, gains credibility with each interstellar discovery. If organic molecules survive interstellar travel, complete microorganisms might also make the journey. Extremophile bacteria on Earth routinely survive conditions that would destroy most life forms, including vacuum exposure, radiation doses, and temperature extremes. Laboratory tests show certain Earth bacteria can survive simulated interstellar conditions for over 1 million years when protected inside ice or rock. If similar organisms existed in Atlas's home system, they could have traveled to our solar system as frozen passengers, awakening when solar heating began, sublimating their icy transport. We may be detecting the descendants of alien microbes delivered by interstellar comets throughout Earth's history. The reverse is also true. Earth's organic compounds are constantly launched into interstellar space by asteroid impacts and comet collisions. Microscopic rock fragments containing fossilized bacteria have been ejected with sufficient velocity to escape the solar system entirely. Computer models show these fragments can travel hundreds of light years before being captured by other star systems or destroyed by stellar radiation. In a few million years, Earth's biological signatures will reach the nearest star systems, potentially seeding new worlds with terrestrial chemistry. If life exists elsewhere, it may recognize Earth's molecular signatures as evidence of a living world. The galaxy could be filled with biological calling cards drifting between stars, creating a vast network of chemical communication spanning hundreds of light years. September 2026. Atlas fades below detection thresholds, becoming another point of light indistinguishable from background stars. Its brief visit ends, but the questions it raised will persist for decades. How many similar objects cross interstellar space right now? Are we living in a galaxy filled with wandering comets and asteroids, ejected from birth systems and doomed to drift until captured by another sun? Sky surveys now dedicate significant observing time to hunting hyperbolic trajectories and unusual velocities. The hope is detecting the next Atlas while it's still inbound, maximizing study time before it vanishes back into cosmic darkness. Every new discovery refines our understanding of galactic connectivity, the web of chemical and biological exchange spanning hundreds of light years. Atlas measured 20 kilometers across and traveled at 130,000 miles per hour. Those numbers alone make it the largest, fastest interstellar object ever detected. But size and speed tell only part of the story. Atlas carried water, organic molecules, and possibly primitive life forms across the galaxy for millions of years, finally releasing them into our solar system as it died. We think of alien worlds as pristine and isolated. Atlas suggests otherwise. Planets may be contaminated with chemistry from dozens of previous star systems, creating galactic webs of biological connectivity that span vast distances. What we consider purely terrestrial life might actually be the descendant of compounds that originated elsewhere and traveled here on cosmic arcs like Atlas. In Chilean desert archives, astronomers found 26 pre-discovery images of Atlas spanning from May 21st through June 29th, 2025. Chemical analysis of microscopic particles collected during this period reveals isotope signatures matching no known solar system source, fragments of an interstellar visitor that fell to Earth as meteors, carrying alien chemistry from another star system directly into our world.